In order to really understand kinematics curves, it becomes important to not forget what's been repeated constantly in class. Given a position time graph, the slope of a position time graph will result in your velocity. Likewise, the slope of a velocity time graph will give you your acceleration. If you don't forget this, the kinematics curves should become slightly easier. They're not the easiest thing in the world. So if you have a little difficulty with them, it's not a problem. You just really need to remember that the slope of a position time graph will give you the object's velocity, and the slope of a velocity time graph will give you the object's acceleration. So to take a look at an example, let's take a look at this given position time graph. Well, if we want to generate a velocity time graph and an acceleration time graph, we just have to remember that the slope of a position time graph will give us our velocity, and the slope of a velocity time graph will give us our acceleration. So if we take a look at our position time graph, well, if we want the velocity, then we need to look at the slope. So the slope of this line right here is both constant and negative. If it's constant and negative, well, constant negative slope on a position time graph must mean constant negative velocity. So for the velocity time graph, it must be constant and it must be negative. So if we draw our velocity on our velocity time graph, it should be constant and negative. So hopefully you remember that the slope of a position time graph gives us our velocity. Likewise, the slope of a velocity time graph gives us our acceleration. So during this period of time, what is the slope of our velocity time graph? Well, hopefully you see it's a horizontal line, meaning we have no slope, and therefore our acceleration is non-existent. We have zero acceleration. So just to recap, we have constant negative slope of our position time graph, meaning we have constant negative velocity. We have no slope on our velocity time graph, which means we have no acceleration. This is one of the easier examples. If you're on board with this, excellent. But let's take a look at one that seems to really trick a lot of people. So as soon as we have a position time graph where the object crosses the origin, that seems to trick some people. But if you really just think about it, the object just started a certain distance past some reference point, a chair, a garbage can. Let's say it's a garbage can. Well, this person or object started past it, then traveled back towards it, walked past it, and continued walking past it in that direction. So they started on one side of the object, walked past it, and continued on the other side. But if we would like to draw the velocity time graph, we only have to remember that the slope of a position time graph will give us our velocity, and the slope of a velocity time graph will give us our acceleration. So if we take a look, if we look at this slope, we should notice immediately that the slope is both constant and negative. This should probably ring a bell from our previous problem. We have a constant negative slope in problem 1. We still have a constant negative slope. Well, what does the slope of a position time graph give us? Well, it gives us the velocity. So if we take a look, we have constant negative slope on our position time graph. So once again, we should have constant negative velocity on our velocity time graph. So if we were to draw this in, it should look something like this. So constant negative slope means constant, not changing. If it was changing, we'd have a change in the y variable. Constant negative, below the origin, constant negative velocity. Now, if we want to figure out our acceleration time, well, acceleration comes from the slope of a velocity time graph. So if we take a look, the slope of this line, hopefully you see, is 0, and therefore our acceleration is non-existent. We have no acceleration because we have constant, unchanging velocity. So we have 0. So constant negative slope means constant negative velocity. No slope on a velocity time graph means no acceleration. Well, let's start to take a look at a third example. I think most people get the first two. This is where we start to lose some people. If we take a look here, I'm going to go ahead and draw some small slopes in, so hopefully you can see what's happening. Well, if I take a look at the beginning of this position time graph, I'm just going to draw a line that's tangent. So I'm going to go ahead and draw a line at the very beginning. Now, if we take a look at the very, very beginning, at this point right here of this line, my slope is actually very, very positive. Okay, and if we take a look about halfway through, if I draw one here, about halfway through, oh, apologize, that didn't register. If I were to draw another tangent line about halfway through, well, that slope is a little bit less, but it's still positive. And if we take a look at the very end, well, the slope at the very end is 0. So the slope of our position time graph is going from very, very positive to less positive to 0. And if we remember, the slope of a position time graph gives us our velocity. So if we go back, it's too far, well, our slope is going from very positive to less positive to 0, and the slope from a position time graph should give us our velocity. So first things first, we should start with a very high positive velocity. Halfway through, it should be a little bit less, and at the very end, it should be 0. So I should be winding up at 0, and we're not going to deal with any accelerations that are not constant in this class, at least in terms of graphing. So if we take a look, our velocity time graph should look like this. Why? Well, our initial slope of this line is very high and positive. Well, about halfway through, it's still positive, but it's a little bit less, so this is less positive than this point. At the very bottom, we reach 0, so you should have 0 velocity. If we want to go from a velocity time to an acceleration time graph, well, then we just have to go back and take a look at our slope of the velocity time graph, because the slope of a velocity time graph should give us our acceleration. So if we take a look at the slope of this line, well, you should notice it's negative. It's also constant. Well, a negative constant slope on a velocity time graph should tell us that we have negative constant acceleration. So if we take a look over here, we should have a negative acceleration, and it should be unchanging and constant. Let me do that in red so I don't confuse you. So we should have a negative constant acceleration. The slope of this graph gives us our velocity. The slope of this graph gives us our acceleration. I'd like to look at one more problem. We may be given a velocity time graph instead of a position time graph. Same process, but you might have to think about things a little bit differently. So we know that velocity comes from the slope of a position time graph. So right now we have positive velocity. We have positive constant velocity. So if we take a look, this right here is positive and constant, which means that for my position time graph, I must have positive constant slope. So I must have a positive constant slope. So if I assume we're starting at 0, I should have a positive constant slope. It makes sense when you look at it. Positive constant slope, I should have a positive constant velocity. Then if we take a look here, well, I have velocity that's starting to decrease. So if my velocity is becoming less positive, hopefully you see my slope should become less positive. So my slope will continue in this direction, but it will become less and less positive until a point where it hits 0 slope. At this specific point, there's no slope. Well, if there's no slope, there should be no velocity, and that would be this point right here. After that, my velocity actually begins to decrease. So if my velocity is decreasing, hopefully you realize the slope of my position time graph should also decrease. So as time goes by, the slope should begin to decrease. And we should have something that looks something like that. So to recap, I have positive constant slope, which means positive constant velocity. Then my velocity starts going from some positive value down to 0. Well, velocity comes from the slope of a position time graph, so my slope should be decreasing and approaching 0, which it does at this point. I have 0 slope at this point. When I reach past that point, my slope actually continues to become negative increasingly. And as you can see, my velocity becomes increasingly negative. These two graphs are connected because the slope of this graph will give me the velocity. Likewise, if I want to generate an acceleration time graph from my velocity time graph, it's a little bit easier. It's just the slope of this graph. So the slope here is actually 0. So the beginning of my acceleration time graph should also be 0 because I have no slope on my velocity time graph. So what this means is if I have no slope, I have no change in velocity over time, meaning I have no acceleration. Then if we take a look at the remainder, you should see I have negative constant slope, which is going to translate into negative constant acceleration. So hopefully you start to see the connection here. The only thing you need to realize at the end of the day is the connection between these three graphs is that the slope of the position time will give you velocity, and the slope of velocity time will give you acceleration.